Hello, and here's a video for finding angles in shapes part 2. In particular, we're finding angles in triangles. So remember in the past we've looked at angles in a straight line that add up to 180 degrees, similar to this one, so angles in a straight line add up to 180 degrees. There's also angles at a point add up to 360, and when you have two lines that intersect, the vertically opposite angles are equal. So sometimes that's also background knowledge here as well. So calculating angles in a triangle. Basically, the thing you need to remember, which if you don't know already, is angles in a triangle, the interior angles in a triangle, add up to 180 degrees. That's the main thing to take away from this. So for example, let's see why. Why did they add up to 180 degrees? Let's see a proof of this. So if you drew a triangle of any shape on a piece of cardboard and cut it out accurately, and then you tore off these three corners. So if you tore off this corner, and this corner, feel free to do it if you like. So make a triangle, cut it out, and then tear off the three corners. And then if you place those three corners next to each other like this, like so the point to that point to that point, and laid them out like this, when you put them together, you would find they form a straight line, which means that these three angles must add up to 180 degrees, because angles which form a straight line add up to 180 degrees. So as I said, the main thing is angles in a triangle add up to 180 degrees. Again, you'll be using algebra. So for example, A plus B plus C equals 180 is a way you could express it using algebra. Some other things to remember is the special types of triangles. Remember, you've got isosceles, equilateral, right angle, and scaling triangles. So specifically isosceles triangles. So isosceles triangles have two equal sides. So remember these sticks. If you're not sure what these sticks mean, I'll just get rid of it so you can see the original drawing. These sticks mean two equal sides. That's what those two sticks mean. So that green stick here and that green stick here mean that these two are equal sides. No, it's equal length sides. You'll notice that this one does not have a stick on it, so it's a different length to the other two. Another thing to do with isosceles triangles is the two base angles. So the two angles formed by the equal side, the equal length sides, are equal. So that angle is equal to that angle, not this angle. So let's get rid of this one. Okay, so those two angles at the bottom are equal to each other. The angles at the bottom of these two sides basically are equal. That one is not equal to that one is not equal to that one, but this bottom one is equal to that one. So they have to be at the bottom of the sides with the sticks. So an isosceles triangle has two equal sides and two equal base angles. The sides AB, so notice we call this line here AB because it connects point A to point B. We call this length, AC, because it connects point A to C. So sides AB and AC are equal, and they're marked with a dash. I quite often will call them sticks. So they're marked with a dash. So angle B, so this means C with a little hat on it, B with a little hat on it, and C with a little hat on it, means angle B and angle C are also equal. So that's an isosceles triangle. Similarly, an equilateral triangle has three equal sides and three equal angles. So equilateral triangle you would draw like this. Feel free to draw it. So you've got your three sides that are all the same length, so you have a dash on each of them. And all three angles, because all three angles are equal, and angles in a triangle add up to 180 degrees, therefore each one must be 180 divided by 3. And 180 divided by 3 is 60 degrees. So that's why each of these is 60 degrees for an equilateral triangle. A scaling triangle has three different length sides and three different sized angles. And a right angle triangle just has to have a right angle in it. So finding angles marked with the letters. So when there's more than one angle to find, you'll quite often find that our exercises are done in a nice way in that they're kind of set up for you to work them out in alphabetical order. So basically if you work out A first, that might help you to find B, which would then help you to find C. Rather than try to find C first, it's not possible until you've got A and B, or A at least. So same thing with this, find P first and Q next, because that's alphabetical order, and it tends to be worked out easier that way. So find the angles marked with the letters. So perhaps try to work in alphabetical order. So we've got A here. So let's say we know that that's 40, We don't know what this one is, so we can't use angles in a triangle for that one. But what can we use to find A? Have a think? That's right, we can use the fact that we already know that angles in a straight line add up to 180 degrees. So that's a straight line there. So this plus this equals 180 degrees. And again, you've got to use algebra. So write an equation for each line. Don't just have a whole heap of numbers flying around everywhere. If you're using algebra, you've got to be using equations and a mixture of letters and numbers, or else it's not algebra anymore. So write an equation, which is A plus 108 equals 180 degrees, because angles in a straight line form 180 degrees. Then start to solve it using reverse steps. So how do we, sorry, I'll just extend this because that's annoying. So, and I'll extend it one more time. So how do we, here we go. Okay, so to deal with the 108, we need to subtract 108 from both sides. So still have A equals 180 minus 108, and then work out your answer. 180 minus 108 is 72 degrees. And don't forget your degree sign. Very important you have your degree sign. So I've worked out A. So sometimes once you've worked out A, it might be useful to write it in. So let's write in A is 72. Because it might not be until you see it written there that you realise, hey, I can do something with that. So now the next one they suggested working out was B. So what could you use to work out B? Well, we know this angle here, and we know this angle here. And what do we know about angles in a triangle? That's right, they add up to 180 degrees. So we know that B plus this equals 180. So we can make another equation with that. So B plus 72 plus 40 equals 180. Next step might be to collect like terms here. You could do that. Collect your like terms. 72 plus 40 is 112. So you've still got an equation. You've still got your B here, and you've got your 180 there, and your equal sign. And then what would you do to deal with 112? That's right, you would subtract 112 from both sides. So subtract 112 from both sides, see it's still an equation, balanced equation, and then work out the answer. The answer is 68 degrees. So again, it might help a lot if you then write that in. That might give you inspiration for how to work out the next part of the question. And now to work out C. Well, probably the easiest way to work out C is the fact that you've put a straight line here. So C plus B equals 180 degrees, and we know that B is 68. So we can write a new equation. We can write C plus 68 equals 180. And C is still an equation. You've got a mixture of letters and numbers and an equal sign. And then you would subtract 68 from both sides. So 180 stays where it is, minus 68. And then work out the answer. You've got 112 degrees. Don't forget your degree sign on your answers. Okay, fabulous. So that's done. Now we've got another one here. So we've got P, Q, and 64. We don't have any outside lines, exterior angles going on, so we just have to deal with the fact that angles in a triangle add up to 180 degrees. But we don't know what one of them is, so we can't just use that. But notice we've got the dashes here, we've got the sticks. What does that tell us about this triangle? That's right, it's an isosceles triangle. So an isosceles triangle because you've got the stick here and the stick there. And an isosceles triangle, if you refer to your notes, the base angles are equal. So the base angles for this one are not these two. They're clearly not equal. Remember, the base angles are at the bottom of the equal length side. So the base angles are these two. See how the base angles are at the bottom of these two? So here's the two equal sides. So turn your head sideways and you see there the base angles. So base angles are equal in a isosceles triangle. So you don't need to show any working out for that. You can just go straight to saying P equals 64 degrees and give some kind of reasoning. So isosceles triangle, for example, would be enough for the reasoning. You could also say base angles are equal. Then you might want to, then you might want to write in that this is 64. Fabulous. So 64 degrees for that one. And then next thing you're going to try to work out is Q. So the only information you have to work out Q is the fact, the only information you have to work out Q is the fact that you know that angle, and angles in a triangle, what do they always add up to? That's right, they add up to 180 degrees. So Oops. So we shouldn't have that one. Get rid of this one. Oops. Something was missing from mine. So I should have had this, but it's been erased, sorry. So it should say Q plus. Let's make sure. See, what was wrong before was I didn't have a balanced equation as my working out. So now I do have a balanced equation. I've got a mixture of letters, because that plus that equals 180. So a mixture of letters and numbers and an equal sign, and terms either side of the equal sign. So 64 plus 64 is 128. So Q plus 128 equals 180. How do we do with the 128? That's right, we subtract 128 from both sides, then work out your answer with a nice little degree sign. And that's the end of the lesson. So don't forget, also vertically opposite angles are equal, and angles at a point add up to 360 degrees. That might be helpful when you're doing this exercise as well. Okay, thank you.